Consulting. Go ahead, Scott.
Thanks, Ben. Hey, everybody. It's great to have you on our call today. We're continuing our webinar discussions, and they've been coming a lot more popular. We are hoping that these are discussions that that you guys are appreciating, and that we're trying to provide a difference in the industry and helping to educate people. As I've started out in every webinar that we've had, I by no means think that I'm an expert, or that any of us on this call are experts in the solar industry, but we like to share and share what we've learned and our knowledge up to this point, and be able to have a candid discussion with you guys on the call. So we are talking about residential batteries today. We've actually had some situations in the designs that we're working on that have been issues with batteries. Either most of them are from a lack of knowledge or understanding of certain aspects of some of the newer batteries that are out there. And I think if we're having similar situations from knowing some of the nuances about newer batteries, then I would assume that most of you guys are having similar issues. We did invite a couple manufacturers onto the meeting. I think we have Everett Brewer. I'm not sure if he's on yet, but from Storage Power, they're a battery manufacturer. And then we also have Ben Lynch from Enphase on the call as well. So we're excited to have them on our call. You guys are welcome to drop into our chat, your contact information. I like to let manufacturers do a little bit of a shout out, so that if anybody's on this call and wants to get some more information, they know who to contact at these manufacturers. We're excited about their participation, and hopefully, if you guys have input that you want to add, you're welcome to just put a chat in there, and we can answer a question as we go along here. Ben will monitor that chat as well. So if there's any questions related to what we're talking about, we can talk about it during the presentation. And then we'll probably present till about 40 minutes past the hour, about 12:40, 12:35, 12:40, and then we'll leave some time open for questions and conversation and discussion. But again, if you have questions as we're giving you the presentation, by all means, drop them into the chat. And if we think it's important for you to kind of chime in while we're having a conversation, we'll maybe turn your mic on or ask you to provide some input. Again, anybody else who's on the call is welcome to ask questions as well. Our presenters today are Catherine Kelso is gonna start off. Catherine has been with us for several months at this point. She's had her own business doing commercial designs. She has an electrical background, electrical engineer, and she's got a vast knowledge of 20 years in the industry. So she will she's going to take the lead on the discussion. And then Greg, who has been a fixture here at Wilson Consulting. Greg and I go back a long time, good friends, and we've been working together for probably about 10 years at this point. And he's going to also chat a little bit about some residential battery conversations that he's gonna discuss. And he's got an extensive background. He's a electrical engineer licensed in all 50 states, including Puerto Rico and the Virgin Islands at this point, and soon to be Canada. And he's also worked in the utility company arena for 25, 30 years, and has an extensive background on interconnections as well, too. And then Heath Harpster has been with us for several years as well. He has a background in structural engineering and commercial applications from a structural standpoint. And he actually just got word that he was approved in Canada. So we currently have our Canadian license for engineering in Alberta. Providence in Alberta will be moving into other provinces there as well. So congratulations, Heath, on that. So I'm going to turn the time over to Catherine, and I'll be available here as well. If anybody has questions for me, I'll probably chime in. You know me, I usually can't keep my mouth shut, so I probably will chime in during the course of the meeting anyway. But so Catherine, I'll turn the time over to you, and thank you everybody for being on the call.
Hi. So our first question in our discussion here is, why would we use batteries? And not that many years ago, we typically would only see batteries when somebody was off the grid. So they either had a PV system or they had a generator, and they wanted power when the PV system wasn't working during the nighttime, or they wanted to not have to run the generator 24 hours a day. So they would put in batteries to store that power. Now we're seeing a lot more grid-tied systems with backup power because the grid is getting less reliable in some places, and people want to run their home off the grid when the grid is down. So when we're looking at grid-tied backup power, one of the questions that always comes up is, what should be backed up? And when you ask a customer, they always say, first they ask, what size battery do I need? And we say, well, what do you want to run? And they say, well, I have a 2,500 square foot house and I want to run everything. And then we find out that they don't have $150,000 to spend on the system. And we back that down to, what should we actually run? What is most important to you during a power outage? And, everyone has opinions on it. There are a few things that are, pretty simple and don't take a lot of power, so it's not a big deal. We can always run lights. We can charge cell phones. We can charge laptops. Most people want their refrigerator running so they don't lose all the food in the fridge. And those things are all fairly simple and can run without a whole lot of, those things can run without a whole lot of power. So, it's a reasonably priced battery system to do that. Then other people, if they live in a cold climate, a very important thing is heat. Well, if they're on electric heat, a backup power system to run electric heat is going to be crazy big. So then we start talking about, well, can you get something that's gas powered, or something, maybe a wood stove or something like that would be a better heat source for you. But if you have gas powered heat, we shouldn't leave out the fact that we need to have the blower for that running. So it's going to be cold, and you can make heat with gas. If it doesn't blow it around the house, it doesn't do you any good. And you also need a little bit of electricity just to keep the thermostat on so that it will power the heater. People don't always think about those circuits, so it's important stuff to look at. Other places where the climate's a little bit warmer, like Palm Springs, sometimes we run into the fact that people want to run their air conditioning because it's 110 all summer, and it actually, not quite life or death maybe, but pretty serious comfort problem if you don't have air conditioning. So you start looking at a whole house air conditioner, and again, the backup system gets pretty big to keep a whole house cool in 110-degree heat. But you can do things like maybe make 1 or 2 rooms set up on a mini split that only runs on a 20-amp breaker. Now you can still have a reasonably sized backup power system and have at least a few rooms that are cool enough that you can go and stay in those rooms during the power outage. So you're not dealing with 110-degree heat, and you're not dealing with a $100,000 battery system. So the whole question of what should be backed up, it's different for every customer, is the bottom line. And determining the size of the battery is a matter of sitting down and figuring out what loads you want to run and how much they need to run, how many hours they have to go, and coming up with how many kilowatt hours you need. Another question that comes up is, should we do a partial backup or a whole house backup? And you run into problems with the whole house backup. And some people will say things like, oh, well, I'll just turn the air conditioner off if the grid goes down and I'm running on my backup system so that my air conditioner doesn't overload the system. And that sounds great until you think about what happens if you're not home. So you've got the air conditioner set on the thermostat, you aren't home, power goes out, air conditioner comes on, and it either overloads the system because it isn't capable of running the air conditioner at all, or the system can provide enough power to run the air conditioner, but it drains the battery in an hour or two, and you come home to a warm house because the air conditioner ran until it stopped running, and then everything got warm and nothing's running. Your refrigerator's now off, and you have no lights or anything because your backup power battery is completely drained. So when looking at the whole house backup, a lot of electricians want to do it for convenience, but if without load shedding, something to turn off the loads that are going to drain the battery too quickly, it can be a real problem, even if the system is capable of doing it it may not be able to do it for very long. And if you're not home when the power goes out and you aren't there to control the situation, it could end up being a pointless battery system because all the power drained before you got home. And it's a problem. So it usually is best to separate loads onto a backed up load system, only the essential things, so that even if the power goes out when you're not home, the air conditioner is turned off and the fridge is on and your backup system isn't drained and it works the way it's supposed to. Another reason why we would use a backup system is for peak power offset, or what they call energy arbitrage. So this is all based on time of use electric rates, where you're paying more per kilowatt hour for power used during the peak time and less for the kilowatt hours used during off-peak time. And one of the places that there's a stark difference in this is in California, where peak usage power can now sometimes be over 40 cents a kilowatt hour, while off-peak can be 15 to 20 cents a kilowatt hour. So if you're doing straight energy arbitrage, which is not allowed in a lot of places, you're actually taking the power from the grid during the cheap time, putting it in the battery, and then during peak time, actually feeding that power back to the grid. What's allowed in more places is just offsetting your power usage. So especially if you have a PV system, the PV system is charging the battery, and the PV system isn't necessarily running during the peak time. It's running a lot of hours during off-peak time. So instead of feeding that power to the grid, you're putting it in the battery. And then when it's peak time, you're using the power from the battery. You're not necessarily feeding it to the grid for a dollar amount, but you're using it from the battery instead of using it from the grid during that peak time, so that you're not paying that high rate for it. Another, and I kind of touched on it a minute ago, is self-consumption is another reason to use the batteries for your peak usage offset, and for any time that you're in a market like California, where if you feed power to the grid, you don't get good credit for it. You'll get a few cents per kilowatt hour during most times of the day. And considering with solar, it generally costs 6 to 7 cents per kilowatt hour to generate, you're going to lose money if you're selling it to the grid at 4 cents a kilowatt hour. So you're better off, as your solar is producing and you're not using power in your home, you're better off to save that power in a battery rather than feed it to the grid. And then when you are needing power and your solar is not producing, you're pulling the power back out of the battery. So that would be self-consumption, and that's going to work in a place where there aren't good net metering rules that are favorable to the customer. So now I'm going to hand it over to Greg to talk a little bit more.
Can I interrupt really quick, guys? It looks like
Absolutely.
the chat feature isn't working with Microsoft having their issues. So if you could just hold your questions, write them down, hold them till the end. We'll open it up for questions then. So make sure you do that, and then we'll open the time up for the manufacturers too to share their information. So thank you. Go ahead, Greg.
Thanks, Catherine. Thanks, Ben. Welcome, everybody. Good to see a lot of familiar faces in the attendance roster and some new ones as well. Appreciate your participation here. Hopefully it's as productive as you were expecting. Choosing batteries. What kind of batteries should you use? And what are the considerations for each of those types? There's a number of them on the market. Lithium ion probably at this point in the market cycle is the most common, most familiar one that a lot of people have heard about. There are other ones out there. There's lead acid, which is everybody who drives a vehicle has a lead acid battery in their car for their starter. If you have a internal combustion engine style, those have been around for over 100 years. There are other ones now that more recently, supercapacitors have entered the market, and lithium iron phosphate also is part of the battery chemistry that's out there. There's pluses and minuses for each of them, and I'll reserve the assessment of that for you to take a look at on those. Voltage is another concern. What do you want to do with the batteries, and what does it mean if you have a 12-volt battery versus a 48-volt battery versus one that'll go 350 or 400 volts? With the concept of power, meaning voltage times current, if you go higher voltage, then you can reduce the current and thus reduce the size of the conductor from the batteries to the inverter, and reduce some expense for wire, because as we know, copper wire is really expensive. There's some folks are touting themselves as AC batteries, but unless you actually have a inverter with the ability to do a DC battery straight coupled with it, all of the battery stuff out there is AC batteries, in that there's an inverter coupled with a storage device, and they plug into an AC bus service panel. So don't want to get that confused. Much like the AC solar panels are out there, it is a true DC panel with an integrated microinverter underneath the module. That is what that is. Or effectively, if you're using technology with microinverters on the rooftop, it's the same type of thing. But you got to be careful with that to match the battery to the technology that you're using to plug it in. You can't use a high voltage battery with a low voltage inverter system. It's not going to work. So be careful with that. If you have questions about that, consult the battery manufacturer or us. We can talk with you about that to help make sure that you are making the right choice as it relates to the type of battery and your need. Codes. Well, take and drop the S, and the code is a 4-letter word. Not a lot of 4-letter words are helpful, but when it deals with energy production, code is our lifeline. We have to abide by it. We have to follow it. We have to make sure we're designing and engineering accordingly to that. And that's the reason we're having this conversation is to make known to you some of the resources that are available, specifically battery location. Now, Catherine talked about cold temperatures and hot temperatures related to lifestyle. Well, they also apply for battery locations. So just as you want something to be able to work in Palm Springs, you also want the battery to survive the Palm Springs temperatures. It gets to be 114 degrees without any problem there. What do you do with a battery that can't survive there? Well, you're going to have to figure something out to either keep it shaded or bring it inside a garage, or work with your design firm to find a battery that can tolerate a bit more extreme conditions. Cold weather, the same situation. The one thing on the cold weather side to be cognizant of is that even though the ambient temperature for a given market might be 5 degrees above zero, for example, and the battery says it can handle a 5 degree above zero temperature at its low extreme, that's a continuous condition for an extended period of time before the internal workings of the battery system would ever get that cold. In energy production, heat is a byproduct, always. So there is some measure of residual heat that is occurring just in the transformation of power from the battery source to the inverter to the grid. That to get that cold and for that battery system to completely shut down, it would take a tremendous exposure for a long period of time. So that's usually not as difficult as the flip side is on the high end. So you got to be careful with that to make sure that you're cognizant of that. Now, as it relates to these 3-letter acronyms here, IFC, IRC, NEC, local codes, International Fire Code, International Residential Code, International Building Code, the NEC, National Electrical Code, all have items in them related to the proper engineering, design, placement, connection, protection, all of those items related to storage power devices. For example, in California, there are strict regulations about having a battery in a garage. If you're going to put it on an end wall opposite the overhead door, you've got to put bollards in there. Or, in an extreme case, make sure that it's at least 3.5 feet off the floor. So if you have a wayward foot and have a slip incident and the car happens to go a little bit too far into the garage, you're not going to crush the battery. Similar type things on sidewalls. are in place along a driveway, not necessarily only in California, but just making sure that the storage device is protected from impact from a vehicle. Other conditions relate to a heat detector for fire incidents, depending on the technology. Ventilation is another concern that has to be addressed, fire alarms and so forth. A number of different things related to that. Again, we can help you out with understanding what those code requirements are and make sure that it gets engineered accordingly. And also to work with the manufacturer to see that this gets installed to their standards in order for there to be warranty coverage should anything happen. Okay, next slide, please. So, electrical considerations for home power use. The reason for this typically is to back up loads in an emergency, like was alluded to earlier. And it's ironic that I spent 25 years working for power companies. We tout that the power never goes off. Well, reality is, no, that's not the case. Every power company has a specific measurable reliability number, both related to the frequency and the duration of outages over their entire service territory. And some have spot areas that are bad, and there are other spots that have no interruptions, depending on the service area and trees, creatures, what have you. But the bottom line is we've all experienced a power outage of some sort at one time or another in our lives. And storage batteries offer a way to ride through that and provide a measure of safety and security and cost savings, because the items associated with our daily lives aren't lost. Most importantly, food. Most of the time we think about food storage and refrigerators and freezers and such, and maybe a means of being able to prepare that. But like Catherine was mentioning, the one thing about a power outage that you notice right away in the summertime is stagnant air. Everything stops, air stops moving. Stagnant air gets to be perceptually a little bit unbearable quicker than it would be if you had a fan running. Even though the compressor was off, but the fan was running, you'd still have the ability to at least have some moving air to draw cooler air from the rest of the home in order to give you a longer period of time for not getting heated up. But on the flip side, on the cold environments, crucial for human survival, to be able to have the blower running if you have a forced air gas furnace, or to have the circulation pumps if you happen to have a boiler system. Those two conditions are crucial. So you want to factor those into your designs. Battery versus generator. When should you use a generator? If there is something that is a high demand thing that is likely to drain a battery over a short period of time, and by that short period of time, I mean when the PV system stops until the sunshine turns it back on the next morning, that 6, 7, 8, 10, 12-hour period of time, depending on when it is during the year, that's your crucial period. And if you can't reliably back that up with batteries, or if the economics are such that it becomes less feasible, maybe a storage battery isn't the best option. So that's something to consider. AC coupling versus DC coupling, roughly talked about that. The example for DC coupling would be an inverter that has, one inverter manufacturer comes to mind that has their own battery that is a high voltage battery and is connected to the inverter directly with no additional energy conversion device needed. It's a 400 volt battery and their system operates at 400 volts, so it's DC coupled directly to the inverter. That's one method. The AC coupling is other ones like the ones shown on the slides, where you have an inverter and a battery combination put together to be able to plug into the grid. and provide backup capability or any of the other reasons for using storage. It matters because you need to make sure that you are purchasing the right equipment. You can't buy a DC battery for an AC coupled system. And typically, if it's going to be a DC coupled system, the batteries are going to be a little bit higher voltage, but that's not always the case. Some of them allow for different voltages. So like PV running at 300 to 400 volts and a 48 volt battery is an option there too. So again, those are questions that we can help you answer. Where should you plug in is another question. Okay, how do I plug this stuff in if I get it all? Is it connected to the supply side of your service, meaning is it ahead of your main service disconnect, your main breaker in your house, for example? Or is it somewhere on the load side because you have a garage that has a nice panel and room off the main part of the house to be able to interconnect? That would be a load side connection. We can help identify that and help you make the best decision from an economic standpoint as well as a safety standpoint and a product life expectancy standpoint. Another option that's out there right now that most of the storage system manufacturers are working with and have a means to do is called power control systems. With the adoption of the NEC 2020, there was provision made for battery management systems, energy management systems for power production setups to be able to keep tabs on what is delivered to the service panel. With that option out there, it used to be, well, we had to limit ourselves to 20% of the bus rating, or we can go to 100% of the bus rating if there's one interconnection point, or we do a service upgrade. But a lot of times the service upgrade is not feasible because of the expense. I mean, equipment costs are continuing to go up. Delays for delivery are a real thing, and the expense of having a licensed electrician come in and replace your service panel gets quite expensive, to the tune of somewhere north of $4,000 to $5,000 or more, depending on the service entrance size. What do you do in that situation? Well, the development of PCS gives you the ability to tell the control system, I have a 200 amp service. My usage justifies the ability to interconnect up to 100, 150 amps of solar production plus some storage. It would be overwhelming the panel as per a specific code article. Are we dead in the water? And the short answer to that is no. The development of 705.13 under the NEC 2020 gives you the ability to implement power control system measures to monitor your usage and the system capabilities and allow for your system to offset power company power demand as needed up to the limit of the system or the panel, whichever is higher, or whichever is lower, actually, misdemeanor, whichever is lower. If the power system, if your production system is capable of delivering 100 amps of power, then that's would be your limit. Or if it's more, it will constrain it to the rating of the service panel. But the bottom line is, it gives a lot more flexibility and control for a producer, a self-producer, to be responsible for all of their demand, and help you separate from the burden of a high power bill. The flip side of that is you can also avoid a service upgrade, because you're not going to deliver any more than the panel will handle. And the other thing that comes along with that is the benefit of allowing the permitting authorities, the inspectors and the plans reviewers, to relax a little bit when it comes to scrutinizing whether or not that 100 amp system can even be installed on your home, because you're allowing the power control system to do the management for you, and they understand that that's a real thing and that it can do this, and they are a lot more friendly towards allowing these things to be installed, and it works great. We have a lot of success with our clients in saving their homeowner client easily $3,000 to $5,000 when they don't have to do a service upgrade. It works amazingly well. It's taken a while for us in the industry to be able to fully understand what that can do and help be working with the manufacturers to help understand what settings are necessary for provisioning in order to deploy this technology. But we've got great resources out there. The folks we've been working with in industry have been very, very helpful in getting this implemented so that we can help our clients realize the full benefits of what can be done here. Okay, Catherine, let's move on to the last one here. I'm going to turn over the rest of the time here to Mr. Heath Harpster to talk through some of the specifics about structural considerations.
Thank you, Greg. Yeah, so for residential battery systems, the structural considerations are pretty straightforward. Usually don't have to worry about too much. I'd say 90% of the time, you probably just follow the manufacturer's instructions, which would be you have a mounting plate, you screw it to the studs, and you put the battery on there, right? Sometimes the HJs are a little bit more picky and they want site-specific calculations. I don't think I've ever seen something fail. Usually these are designed with abundance in capacity to handle all those conditions in a residential sense. What these batteries weigh usually around 300 pounds. You have 3 to 4 screws into a stud. You're going to have enough capacity. There are a couple occurrences that you need to consider though. So when you have a brick veneer on a house, you want to try to avoid those. Brick veneers are not a structural element, like connecting to a stud wall. They're only attached back to the stud wall with a couple clips, and it's just to support its own self-weight and it pulling off the wall. If you add a battery to the brick, you're adding 300 more pounds, and that brick's going to try to pull away from the wall. Our recommendation is to avoid them completely, or you can screw through the brick veneer back into the studs. When you do that, you usually drill a pilot hole through the brick, try to find the stud, and then you install a steel pipe. And that's going to act as basically a large washer to add support to that screw to get through the brick and back into the stud. And then another occurrence that you could have is when you don't want to mount to the structure, whether it's like a manufactured home or a mobile home or something where maybe the walls aren't sturdy enough that you don't want to mount to, or you might want to be out closer to the pole or something. You can do one of these racks in which it's basically the same as how you'd mount stuff to a ground mount, right? You're going to have those 2-inch, 3-inch steel pipe posts buried in the ground, and you're going to run unistrut between them, just like you would for a ground mount, but you're going to have these poles sitting by themselves, and you're going to make all this racking yourself to mount all this equipment to. You can have multiple unistruts going across where you don't, you might not just have a single battery mounted to it. You might want to add other equipment as well. So yeah, those are pretty much the only other things other than maybe mounting it to a concrete slab or something, but you don't usually get into that too much in residential. So I'm going to turn this back to Catherine and Scott to wrap up. Thank you.
Was there anything else that we needed to chat about, Catherine, or?
No, we'll take questions next, I think.
Yeah, thank you guys for your diligence in preparing this presentation. I apologize that there's something going on with Microsoft, so we did not see any questions come through. It seems we were able to use the chat between the presenters, myself and Catherine and Greg, but I don't think anybody else has seen those chats. So why don't we open up the time now for questions that you may have, and if those individuals from Stores Power and Enphase, if you want to introduce yourself on the call, that would be great. I know you're not able to drop your email in, but maybe you can tell us what your email is, and people can write it down. I apologize for that. So, and if anybody had questions, let's identify them. And I don't know, are we able to raise hands here? Is that what we're doing on this call now, or we're not able to do that?
That's what I was hoping for, is people raise their hands. They can ask questions.
Catherine, why don't you stop sharing your screen so we can see everybody on the screen?
Can someone go ahead and see if they can raise their hand, if we can see it?
I'm not sure about hand raised, but Everett's got his mic open. Everett, you want to go ahead?
Oh, yeah, I see Everett's
Yeah.
hands now. Yeah.
Well,
Hi,
there
Everett.
he
How
is.
are you?
Yes, doing great. Good to see you guys.
Thanks for
Appreciate that.
joining. Are you still there?
Yeah, can you see?
Yeah, thanks for joining. Why don't you just tell us a little bit about Storage Power, and maybe if you want to, give your cell number out or an email, whatever you want to do, you're welcome to do that.
That's right. I'll just give Greg's cell phone number out, but yeah, Everett Brewer. We're headquartered right here in Utah. We're a global company, been in business for 12 and a half years, CEO here at Storage Power. Really appreciate you guys putting the time and effort into some of these main questions. I mean, these things that we get all the time. Greg and I are always on a thread somewhere talking about making sure we're providing extra value and answering additional questions and concerns in the ever-changing vast infrastructure and policy places that we work and live in. Would love to hear from anybody that has any questions or concerns. We'd love to help with education as well. You can actually reach us at storagepower.com, STORZ power.com. You'll in there be able to contact us, set an appointment with a Storage Power specialist, and we'll get right into it. So we've done everything from the mega mansion down to the residential market, and of course we have a full CNI product as well. And would love to see what we can do to help you guys and deploy these systems accurately and safely, and making sure that we have the best handoff as possible. How we look at it is that the more education you guys have, the better handoff, because I'm the one that's married to them through the warranty, through the performance, and all of that is based off of how we are going to partner in making sure these systems are accurate, efficiently deployed, and expectations are set accurately. So I appreciate you guys putting the time and resources into this. Love to see more of this happen in the industry. Look forward to the next go around.
Thanks, Everett. Appreciate it. And then Ben Lynch, right? How are you, Ben?
I'm doing well. Happy to be here with everybody on the call. I am Ben Lynch. I am the FAE and Design Manager for Enphase Energy. And obviously batteries are something that is coming to every region right now. A hot button issue in California. We are currently offering our 3rd gen solution with System Controller 3 and 5P batteries. Happy to talk more about that with anybody who has questions on the product or anything future on the roadmap. My email you can reach me at is B for Ben, LYNCH for Lynch at enphaseenergy.com. I'd also take this opportunity just to plug the Enphase University. It's a phenomenal resource for training materials about all these new products and just battery concepts in general, as well as our documentation center, which can be found online. All the certification and planning details can be found in one handy dandy location. So a lot of great resources available, including myself. So I'll go ahead and hand it back to the rest of the team. And if there's any specific product questions, I'll be able to chime in and help out.
One other one
Thank
that
you.
came up as well too, Scott. I did see Mike Hall in the audience too. Mike's representative from Lion Energy here in town. Mike.
Hi, Mike. How are you? We're giving you an opportunity just to say hi and maybe give you contact information as a manufacturer of batteries.
Yeah, can you guys hear me?
Yes, indeed.
Okay, perfect. Yeah, we're right here in American Fork. We produce batteries and inverters, Lion Energy. Pretty much covered a bunch of what we talked about and what you guys were talking about. We've been doing a lot with Whistling. They've been doing great, helping us out a lot. And yeah, anybody wants to get hold or contact Lion Energy, my email address would be mike.hall@lionenergy.com.
Great. Well, thank you, guys. Question for the three of you. Batteries are becoming much more prevalent, right? We see things that have changed in in California and imminent changes coming in Illinois as well that are going to put batteries more at the forefront. And I think people are looking to try and move away from being tied into the grid, or they may never be able to do that. Maybe want to be off grid. But I know that there's newer technology that's coming through. I'm assuming all of your companies are working diligently to make sure you're utilizing the best technology on the market. And I'm assuming that prices will eventually start coming down as the demand starts to increase. I'm assuming that there'll be more competition and that'll probably start looking at where the prices are. Can you guys have any comment related to that? Maybe we start with Everett if you want to do that.
Yeah, for sure. Ultimately is there's tons of different innovations and differentiations that we're constantly working on our product set. From a pricing standpoint, I think the number one thing that everybody's on this call can confidently state is that everybody's focusing on domestic content. How we actually start accounting for future pricing control is being able to account for a home base advantage. And I know independently, all three of us have big goals for that. Despite the fact that we're competitors in other ways, we're actually still trying to account for an overall secure United States of America, which I think is very, very important to all of us. Through that, we have the benefits of the IRA. That's a contribution to help us reduce our cost to manufacture these products, making sure they're coming off the end of the line efficiently, providing more jobs, more engineering support, more economics in the United States. And we're going to start seeing some of those benefits here. I would reference here probably in the next 24 months as an entire combined industry standard. As we start seeing more facilities come online and that capacity scaling in that scenario. From an innovation standpoint right now is I think the number one thing that we are focusing on is the overall security of the grid as a whole. Right now, as and has been for a very, very long time, the United States utility infrastructure is the number one asset that's under attack around the clock. And so what can we do to bring security to America to where we have resilience in the case of power outage? We use the word impact here. How can we impact the human element? How can we actually have compounding impact to your neighbors, your businesses, and their lives and their families and their overall assets and protection? And that's where the biggest innovation is coming in right now, is how we can actually look at this as one combined interconnected asset that is able to account for the lives and the structure of our families and our homes and our businesses. And that's really the biggest innovation that we're focusing on. And it's really just right here, right at the heart of the US. So
that's great. Yeah, I mean, there's certainly, we've seen competition coming overseas in a lot of different venues, whether it's batteries or whether it's just even engineering or designs as well, too. And you're right. I mean, trying to make things more productive here and be competitive in the US is going to be important. I agree 100%, Everett. Thank you. I don't know if Mike or Ben, if you guys had any insights. You don't need to feel like you need to give some insight if you don't want to. I don't want to put you guys on the spot.
I think domestic content is a great point. You know, the Enphase just released the 5P domestic SKU as well as the IQ8HC domestic SKU. So those are both eligible for those domestic content rebates, which everybody is looking for these days. So talk to your distributor about that, or reach out to me if you're looking for more information. And then the other component of cost with batteries is often around labor and load relocation. And that's something that we're certainly very sensitive to. If you guys have encountered the Powerwall 3 with the backup switch, that's something that people are looking into right now, although that has had some supply issues from what I understand. The Enphase solution we're looking to have in Q1 will, I think, reach parity with that, if not move past it. Certainly being able to avoid all of that load relocation and create a backup solution that works for the customer with load control and other features is going to be something that I think everyone is looking for moving forward. And so hopefully being able to pair that with the domestic content and reducing the labor costs, we're looking forward to 2025 as an opportunity to present a lot of really cost-effective solutions to our installer partners and to homeowners.
Great. Thank you, Ben. And actually, Jeff, I saw you had your question because I was thinking about the issues you were having with supply chain. and how that's affected your business. So Jeff Weiss is from, yeah.
I'm with a company called Solar Sesame. We're a dealer installer in Northern California, and we've had all sorts of fun with Tesla recently, and allocation and other supply issues. But I had a question, which is, I know that you guys were talking particularly about Enphase and about trying to create some better integrated systems. One of the issues that we're finding, particularly with Enphase, I'm just saying, is space is basically a real estate issue. With, like, say, a Tesla Powerwall, or like maybe a Franklin or something, a large single battery, we don't have as much problem, installing on a house with, say, a lot of batteries on the outside. Is there something you guys are doing to kind of shrink the footprint to make it easier to put some of the larger battery, like backup battery systems, to help us
There
out,
is.
especially? Okay.
Yeah, and I don't want to get too much into detail on this call because that'll derail it. If you're in Northern California, I'll plug that we have some distributor road shows where we're going to talk a little bit more in detail about the roadmap. For folks in other areas, keep an eye out for those as well. Certainly into Q1 of next year, we're going to be on the road talking about that. So don't want to get into that here because that's not what we're talking about, but feel free to see us on the road and we'll talk a little bit about that. But your concerns are our concerns as well on that front. I can tell you we are thinking about wall space and real estate in that way. So hopefully you'll be pleased with what you see, and hopefully I see you out there, Jeff.
Okay.
Yeah, Jeff, do you have Ben's contact information? You can always chat with him directly, right? I think it was B Lynch, right? Is that your email, Ben?
That's right. Just first letter, last name, and at enphaseenergy.com.
There you go.
Cool.
Okay, Mike, did you have any comments, or do we want to just maybe open it up to the group for questions?
I just was gonna kind of piggyback off of what Everett and Ben was saying. Yeah, Lion's keeping things domestic, I think, and looking into that kind of futures kind of market too. I do know they've invested heavily in American Battery Factory, which is being built right now in Arizona. Kind of bring things. They'll be manufacturing the batteries right here. In Arizona, but like I say, we kind of keep trying on that same process of keeping things here, keeping it easy, understanding. We are always working on the future of what's going to be best for anyone, of how our product can be best suited and better adapted. Just to agree with those guys, I think there is a future with it. I think batteries have stepped forward. Solar was kind of the leader for a little while there, and batteries are kind of coming behind it. And I think they work very well together. So it's a good pair, and that's where we're at.
Yeah, no, that's great. And I appreciate the three of you guys being on this call. In my opinion, you guys are the best in the industry because you joined our call. So we're going to continue to follow you guys and help where we can. And hopefully, we can help you guys, make it in this industry. So that's great. We do appreciate it.
Appreciate it.
So let's open it up to the rest of the group. If there's any questions for anybody, any of our panelists, or either Everett, Mike, or Ben, who are manufacturers of batteries, or we'll turn the time over to you guys for the next 10 minutes or so.
Yeah, Scott, if I can just add one comment while we're waiting for the questions to come through. Keep in mind is that the domestic content adder can only be qualified by a commercial owner asset, so a PPA or lease company or a commercial player. So I just want to make sure that there's clarity on that. There's been some confusion to where just a residential homeowner purchasing a solar system can qualify for that extra 10% adder. Unfortunately, that is not how it qualifies. So the PPA and lease companies and then commercial applications are where that's extra domestic content becomes applicable.
Yeah, good point, Everett. Thank you. Anybody, any questions? Any comments? Are you guys, what did you guys think about the webinar? Was it on point, or is there anything we need to cover a little differently? And, maybe if you even have some suggestions for topics you may want to hear more about in the upcoming webinars. We're doing a monthly at this point, and I think that's been well received. I think some of the comments related to our last webinar on commercial designs, that we may have a second commercial design webinar, kind of a follow-up. I think that was valuable for everybody, and we've got some feedback related to that. So any other suggestions or any other questions, guys? Okay, well, we appreciate you guys taking the time out of your busy day to hop on. We're super pleased. I'm grateful for those of you who are working with us to be able to take the time to be on the call. Some of our customers, we appreciate all that you guys are doing and the trust that you have in Whistling Consulting. So we'll convene this webinar until the next one. And thanks everybody for attending. Appreciate it.
Thank you.
Thank you. Have a good day.
Thanks.
Thanks, everybody.